here the complete explanation for the ATPs produced in the metabolic pathways we have discussed so far. And we're going to use this to answer some examples. So we have only 4 examples here. Alright, so let's start. So number 1, maltose converted to carbon dioxide. And when we are given this type of questions, we assume that, for example, here, maltose has undergone glycolysis and Krebs cycle completely, meaning it has underwent everything. And since maltose is 2 molecules of glucose, and in every glucose we produce 32 ATP. And there wasn't any mention of any glycerol phosphate shuttle, so we assume this to be 32 instead of 30. To get the number of ATP from maltose, we simply multiply 32 by 2. So the number of ATP is 64. It's very simple. Now in number 2, we have 3-phosphoglycerate converted to fumarate. And we should be very careful because here we are not assuming that phosphoglycerate here is of 2 moles. Only 1 mole of 3-phosphoglycerate is being asked for here. And from G7, meaning that you go from the step after G7 onwards until you reach TCA6. So if we have G7 and G7 produces ATP, do we involve that? No, because this is the product of the glycolysis step 7. Alright, so if this is the product of step 7, you start with step 8, which is G8. Well, G8 does not produce ATP, so that's G9. So you start with G10. So you count the number of ATPs singly using this one. So if we start with G10 and we're supposed to end at TCA6, right? So we count 1 plus 2.5 is equal to 3.5. Plus 2.5 is equal to 6, plus 2.5 is equal to 8.5, plus 1 is equal to 9.5, and plus 1.5 is equal to 11. So that is a total of 11 ATP. Alright, now 3, we have palmitic acid, which is a 16-carbon fatty acid with no double bond, converted to carbon dioxide. So here, we assume to have 16 divided by 2 is equal to 8 acetyl coenzyme A's. And then we have how many cycles? The number of cycles again is equivalent to the number of acetyl CoAs minus 1, so that is 7 cycles. And remember that each acetyl CoA is supposed to give us 10 ATP, and each cycle is supposed to give us 4. So 8 times 10 is equal to 80, 7 times 4 is equal to 28. Is this final? No. Don't forget that we have a pre-beta oxidation phase which involves usage of 2 ATP. So whatever sum we get here, we subtract 2. So this would result to 80 plus 28 means 108, and 108 minus 2 yields 106. So the answer to this one is 106 ATP produced per palmitic acid in complete oxidation. However, what is the case in number 4? We have linoleic acid 18,2 converted to butyric acid. Alright, I have mentioned this before that you cannot do this this pattern when you do not completely oxidize and you stop somewhere along the way. So in order for us to completely visualize this again, just for the sake of clarifying that point, let's draw the entire linoleic acid. 1, 2, 3. No, let's start with the COOH first. COOH. By the way, linoleic acid has double bonds on 9 and 12. So let's not forget that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, so what we do? We chop this off until we reach 4 carbons because butyric acid is 4 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. Alright, so this is the butyric acid. So we stop at this cycle. So how many cycles did we get? 1, 2, 3, 4, 5, 6, 7 cycles. Alright, then how many ATP, acetyl-CoAs? 1, 2, 3, 4, 5, 6, 7 also. And then how many double bonds do we have? 2 double bonds. Alright. And again, 10 for each acetyl coenzyme A, 4 for each cycle, minus 1.5 for each double bond, and then minus 2 for the pre-beta oxidation. So 7 times 10 equals 70, 7 times 4 equals 28, 1.5 times 2 equals 3, so that's negative 3. So we have 70 plus 28 equals 98, minus 3 is 95, minus 2 is 93. So we produce 93 ATP from the conversion of linoleic acid to butyric acid. So these are crude examples. If you want more examples, then probably I could give them at an actual review class. Or if I have time, I may be able to release more problem sets in the future. But for now, we have already discussed the ATP count for carbohydrates and lipids, and also special cases for more than just one unit of carbohydrate. This one is a disaccharide, in between carbohydrate intermediates, complete oxidation, and partial oxidation.